Hello everybody. Today we will study about sound wave and its characteristics features. So let's begin. In our last lecture, we study waves and their classifications. Today we will focus towards a specific type of a wave called sound wave. When an object vibrates, it creates a pressure disturbance in the surrounding air molecules, generating what we perceive as sound. These vibrations create fluctuations in air pressure, forming a pressure disturbance that propagates through the medium, while the air molecules themselves remain relatively stationary. The energy from the vibrating object is transmitted through the air as a sound wave. In essence, sound is the transfer of energy through the air or some other medium as a series of pressure changes, ultimately conveying the vibrations of the source to our ears. Sound waves are classified as longitudinal waves, and as we have studied earlier, that in case of a longitudinal wave, particles in the medium oscillate parallel to the direction of wave propagation. In other words, the vibrations of the particles occur in the same direction as the motion of the wave itself. This characteristic distinguishes sound waves from transverse waves, where particle oscillations are perpendicular to the direction of wave travel. During one cycle of sound propagation, it comprises of two distinct phases. Number one, areas of compression. These regions of compression exhibit a higher density of particles, with particles closely packed together. This results in increased density and elevated pressure within these regions. Number two, areas of rarefaction. In contrast to regions of compression, regions of rarefaction feature a lower density of particles, where particles are spaced further apart. As a result, the pressure within these regions is lower. Sound waves typically travel in a straight line, maintaining their trajectory, unless encountering changes in the medium that cause bending or reflection. In reference to the sound wave, the particles within the medium undergo minimal displacement from their fixed positions, oscillating back and forth, transferring their energy and momentum to neighboring particles. This mechanism enables the propagation of sound energy through the medium, which can take the form of any matter, for example, solid, liquid, or gas. It's important to note that sound waves cannot travel through a vacuum, as they rely on the presence of matter to propagate. To summarize, sound is a mechanical, longitudinal wave that necessitates a medium for its transmission. To conclude, there are 5 key aspects to remember about sound. Number 1, sound is a type of wave that carries mechanical energy originating from vibrations in a medium. Number 2, sound is classified as a mechanical wave requiring a medium for propagation. 3, sound travels as a longitudinal wave with particles in the medium oscillating parallel to the direction of wave propagation. 4, sound typically propagates in a straight line unless it encounters changes in the medium. 5, sound cannot travel through a vacuum. It requires a material medium for transmission. With this, we end up with the lecture on sound wave. In the next lecture, we will study about piezoelectric material used in medical ultrasound imaging.